Homework 8 is on inverse relations and functions. So we're going to start by looking at number 1, writing down the inverse and then determining if it is a one-to-one function. All right, so we have that capital R that stands for relation. So we are going to use capital R inverse to represent the inverse of that relation. So we have curly brackets, and then these ones, a relation with ordered pairs is super easy. All you're doing is literally just swapping the x values for the y values. So the first ordered pair would be -7, -2, and -3, -1, 5, 0, and 2, 1. All right, so we just swap those. So then determining if it's a one-to-one function, one-to-one means the original R is a function and the inverse is a function. So checking this one, looking to see if there are any repeat x's, and there are not. So this one is a function. And then check here to see if there are any repeat x values, and there are not, so this one is a function. So if the original and the inverse are both functions, then yes, it is one-to-one. Okay, we're going to do something similar with number 3. This one we're not actually stating the inverse, but we're going to say if it represents a one-to-one function. All right, so one-to-one, if the original is a function, that means no repeating x values. If the inverse is a function, that means no repeating y values. Because remember, these y values turned into these x values. So basically, if you're looking at a relation, if the x's never repeat and the y's never repeat, then it's a one-to-one. All right, so these ones, just since they're on a graph, I'm going to write them down. So like this ordered pair right here is -2, 0. This top one right here is -1, 4. This one right here is 1, -2. And this one right here is 5, -2. So one-to-one means no repeat x's, no repeat y's. So if you look down, no repeat x's. If you look down here, that is a repeat of y's. That means it's not one-to-one. Okay, because you've got this y value that is paired with 2 different x values. There is not a one-to-one pairing. So it's just a no for number 3. All right, number 6, we're going to work on finding the inverse of each function. So there is a 4-step process that we have. Step 1 was to replace the f of x with a y. So that's a very easy step, which looks like that. Step 2, interchange x with y. So this y becomes an x. This x becomes a y. Step 3, solve for y. So do whatever you need to do to get the y by itself. So I would start with subtracting the 9 from both sides. So if I subtract the 9 here, I get x minus 9. And then divide everything by a -1 to get that y by itself. So divide by -1, divide by -1, divide by -1. So it looks like that. And step 4, rewrite this y now as f inverse. So we write f inverse of x and then copy down what we ended up with in our last step. Okay, the next set, determine whether the pair of functions are inverse functions. Okay, typo. So this one, remember, this is the composition one where you compose f with g, compose g with x. If the composition both ways comes out to just be an x, then they are inverses of each other. If either one is anything but x, they are not inverses of each other. So we're going to start with f composed with g. Okay, so this, remember, means you are taking function g and plugging it into function f. Okay, so we start with function f. So 6x minus 15, the x will get replaced with the entire function that we have for g. Okay, so it looks like that. All right, so simplify this completely. Distribute the 6. 6 times 1/6 x is just an x. 6 times 5 halves. Remember, 6 divided by 2 is 3, times 5 is 15, and then minus 15. So this comes out to equal x. That's a good start. Okay, so when in one direction the composition works, and then we have to do the other direction of composition. So this time you're using function g and plugging in function f. So use function g, which is this one right here. So 1/6 x, except the x is going to get replaced with this whole function. Okay, so it looks like that. We'll see if it simplifies up to just an x like the first one did. So here to simplify, distribute the 1/6. So 1/6 times 6x is just an x. Minus 1/6 times 15. That's 15 over 6. So 15 over 6 I can reduce down by 3, and I get 5 over 2, and then plus 5 over 2. So when I combine those up, I get just an x again. Another good sign. So this is a yes, they are inverses. Okay, we're going to do one last one on the following page. We're going to do number 14. So this one, we're doing practice finding the inverse again. This time we're going to graph them both and see what the graphs should look like. So same 4-step process that we had before. So step 1, replace f of x with y. Step 2, interchange x with y, like that. Step 3, solve for y. So first thing here is we're going to add this 4 to both sides. So x plus 4, and that will remove it from the right-hand side. And then we're going to multiply both sides by this reciprocal right here. So multiply by a negative 3/2. That's a lot to keep in our heads, so I'm just going to write that out. Okay, so distribute, we have negative 3/2 x. Negative 3/2 times 4, so we know it's negative. 4 divided by 2 is 2, times 3 is 6. Okay, and now that y is all by itself on the right-hand side. So we are going to rewrite, this is step 4, I'm sorry, rewrite it as f inverse. So that's our inverse function. All right, so we're gonna plot them both and then verify the inverse relationship. So this is something that we did a long time ago, plotting just lines. We use the y-intercept and then followed by the slope. So for this one, our y-intercept is a negative 4. So we start at this point right here. Slope is a negative 2/3. So we can go down 2 to the right 3, do that a couple times. And I'll do it in the reverse direction also. So up 2 to the left 3. So that is our first graph. We can connect the dots there. So that's the original. This is just f. And then we can do this with the inverse. So negative 6. And then this slope is negative 3/2. Okay, so we can go down 3 to the right 2. Can't go any further this way, so I'll go in the opposite direction. So up 3 to the left 2, up 3 to the left 2. All right, so these points right here are for my inverse function. Okay, and then verifying that they are in fact inverses of each other. Remember, this is our dotted line that runs right through that center diagonal, and these should be reflections of each other. And you can see visually that they are reflections of each other. So this half of f is reflected in this half of f inverse. This half of f is reflected in this half of f inverse.